Hi everyone. So we are now continuing with the next lesson for chapter 3, number theory and the real number system. And this time we will be talking about exponents and scientific notation. So for this particular topic, we will be converting using properties of exponents, convert scientific notation to decimal notation, and vice versa. We'll be computing some scientific notation and of course solve applied problems using scientific notation. So first things first, this is a quick review of the properties of exponents. So by default, we have like 5 different rules for the properties or for use working with exponents. So the very first one is the product rule. All right. So pretty much what happens in the product rule is if you have the same base, so remember our base is the number being multiplied to itself. All right. So if we have the same base and we are multiplying two numbers with the same base, all we need to do is add their exponents. All right. So for example, if we have, let's say we have x squared, y to the third, multiply it by x to the fifth, y to the second. Okay. So if we multiply this, we're going to take a look at the numbers or the variables that have the same base. So in this case, x and x. X here has an exponent of 2. X here has an exponent of 5. So if we are multiplying x squared and x to the fifth, it's actually going to be x 2 plus 5. The exponent 2 plus 5. Y, on the other hand, has an exponent of 3 multiplied with a y exponent of 2. So that's going to be y 3 plus the exponent 2. So if you simplify, the product will be x to the 7th, y to the 5th. All right. So again, if you have the same base, simply add their exponents. Now, the power rule, on the other hand, you have a power raised to another exponent. So in this case, if you have a value that is being raised to another exponent, what you need to do is multiply the two exponents, and there we will have some example here. So let's say if we have w to the third times z to the second. Let's say we will raise this thing to the fourth power, okay? So in this case, all of these variables will be raised to the fourth power. So we can split this up as something like w raised to the 3 times 4, and then z will also have its exponent 2 multiplied by 4. And so when we work on this, this is going to end up to be w to the 12th power, and then z is going to the 8th power. So this exponent gets to be multiplied to this and to this exponent here. The quotient rule, as you can see with product rule, we added the exponent. So when we have quotient, again, if they have the same base, what we need to do now is to subtract the exponents. So let's say we have x to the 8th, y to the 9th, z to the 7th. Divide it by, let's say, x to the 4th, y, and then z to the 2nd. Okay? So again, you can only apply this on similar bases. So if we're going to take a look here, x has an exponent of 8 and 4. So that would be x, 8 minus 4. Our y would be what? 9 minus, y doesn't have an exponent. So technically, there's an invisible number 1 over here. So that's going to be a y minus 1. And then z is raised to the 7th and to the 2nd power. So that's going to be 7 minus 2. And so if we simplify this, this is going to be x to the 4th, y to the 8th, and then z to the 5th power. So that is how you will be working with product rule, power rule, and quotient rule. Now, earlier, I mentioned that there are 5 laws of exponents. So the next rule is what we call as the zero exponent rule. The easiest way to say this is anything that is raised to the 0 power is going to be equal to 1. All right? So for example, if I have pi raised to the 0 power, doesn't matter if pi is 3.14. The fact that the exponent is 0, it's just 1. Even if I have, let's say, 1 million raised to the 0 power, that value is still 1. Okay? Now, if we have negative 5 raised to the 0 power, okay? Again, be very careful. You have two different operations here. Multiply by negative 1 and the exponent 0. So by PEMDAS, we will work on the 0 exponent first. So 5 to the 0 power is going to be 1. And this negative here is going to be like that. Okay? Remember, this is different if you have the quantity negative 5 raised to the 0, this is going to be positive 1. But this one, as you can see, the 0 exponent only belongs to the number 5, not to negative 5. All right. Now, moving on, the last rule or last law of exponent is what we call as the negative exponent rule. So whenever you have a negative exponent, and you must remember, negative exponents are never allowed in an expression. So all you need to do to make that exponent positive, is to write the whole thing as its reciprocal and then use the exponent as a positive version. So let me give you an example. So let's say I have 8 to the negative 2, okay? So we want 2 to become a positive. So what we will do is we will use the numerator 1 and then our value 8. Now, negative 2 will now change to the exponent positive 2. All right? And if we simplify this, this is going to be 1 over 64. All right? Now, if you happen to have, let's say if you happen to have expression, all right? Let's take a look here. So where's my, okay, there we go. So let's say we have x to the third, z to the fourth, okay? All over y to the negative 2, and then you have z to the 7th, all right? So we know that we need to subtract exponents of the same basis. Now, when you have the exponent, negative exponent on the numerator, it will simply just go to the bottom, all right? But if you have an exponent that is negative in the denominator, it will just go to the opposite place. So that is going to be up here. So can we simplify anything with x? So x is in the numerator, nothing in the denominator, so x to the third stays by itself, all right? Y, on the other hand, as you can see, y is raised to the negative 2, but it is in the denominator. So this will now go up in the numerator to make it a positive exponent. In the case of z, we know that we need to subtract the exponents. So this is going to be z. The z is going to be z to the fourth minus 7, which will give us z to the negative 3. And you know that when we have a negative exponent, that goes in the denominator. So z will be placed in the denominator. So this is the final answer in our exponents here, the exponent rules. All right? So that's it for exponents.